So welcome back friends, welcome to Aayu Pathshala. And in the previous video, we have discussed that the network layer is responsible for delivery of the packet from one host to another host, or for simplicity, let us say from one computer to another computer, moving the packets or routing the packets through a various number of intermittent nodes, which is done by the routing protocols. So once the packet reaches to the desired PC, and we have seen that the how the mapping of the logical address with the physical address is done by the various protocols, such as the ARP and the RARP protocols. So now, once the packet is reaches to the computer, now within the computer, there are large number of processes which may be running simultaneously, and you can check that also. You can press Control Alt and Delete on your Windows PC. That will open up a task manager, and you can see that there are large number of processes being running. Now, to which process the packet need to be delivered will be decided by which layer. So that would be the responsibility of the transport layer. And today we will be dealing with the transport layer. So this is like the our channel, Aayu Pathshala. And if you are new to it, kindly subscribe to our channel. And the entire notes of the this video as well as the previous video is available on this Telegram channel, that t.me/apdci2025. You can go visit this Telegram channel and can also download the notes, and also the previous videos with respect to the computer architectures and operating systems are also available. So in the operating system only we have done the process, and where we have seen that there are multiple processes running on the PC. So we have completed the data link layer, wherein we have seen the Ethernet frame structure. In the network layer, we have seen the Internet protocol frame structure, that is the different headers, segments in the different headers, and with different parts in the header and the variable length of the headers, and the payload section we have completed with that. Now let us move to the transport layer and start the transport layer. See, transport layer is basically responsible for delivery from end-to-end delivery. End-to-end delivery means, if you remember the practical real-world analogy of delivery of the packets, you have reached to the hostel gate. Now, within the hostel, you know that it is the hostel number A, where the packet is to be delivered among the hostel number or between the hostel number A, B, and C. The packet has to be delivered to hostel A, but the actual delivery to which particular room, A1, A2, or A3, is the responsibility of the transport layer. That means in the transport layer, we have what? We have what is called as this segment. The transport layer, what we have as this segment. So from segment, we have seen the datagram in the network layer. From datagram being converted to frame, Ethernet frame, and this frame is then transmitted bit by bit over the physical layer. This is the frame on the data link layer. So this we have seen when we are transmitting the uh, information from the application layer. Here we have the application layer, presentation layer, session layer, and then the transport layer starts. So the reverse will happen when we receive the packet. So these bits will be received by the DLL layer, then it will forward it to the network layer for the transmission, and network layer will give it back to the transport layer, and network layer will deliver it to the computer or the PC, and within the PC, the transport layer will ensure that the packet gets handled to the right process. So this is what the transport layer does. So within the transport layer, we will be seeing majorly two protocols. One is called the UDP, and another is called the TCP protocol. And among these two protocol, UDP protocol and TCP protocol, the most important protocol is the TCP protocol. But before we proceed to the TCP and UDP, let us understand what is the port number. See, if you closely observe the IP addresses, for example, any IP addresses on, for example, the IP address of a website, for example, Google. Go to the Google and type what and find out the IP address of google.com. So For example, I don't know what is the actual IP address of the google.com. So for example, 129.7.7.8, if this is the IP address, you will find that this is like the address of the server, and after that the port address will be given, port 80 for HTTP or port 443 for HTTPS. So this is the complete address. That is the IP address plus the port address, which port you have to deliver. Okay. So this is the complete address. So the every process is being allotted some port number. For example, we have some predefined port number. You can define it manually for some process, but there are predefined port numbers. For example, for HTTP application, we have port 80. For HTTPS, we have port number 443. So you can see over here, for HTTP, we have port 80. HTTPS, we have 443. FTP, we have port 21. DNS, port 43. SMTP, port 25. So basically port number, what it does, it identifies the process on a host. You have reached to a particular PC, but in that PC, there are different process running. To which process I should handle over the data? That is called the identify the process on the host using its port number. So if you see the analogy, it is nothing but IP address is the house address and port is nothing but the room number. Okay, apart from that also, we have seen that there is like the error control, flow control, and congestion control, and that is being done by the data link layer. We have already seen the data link layer, three important function. Apart from MAC addressing and the framing, we have error control mechanism, detection and control. We have flow control, and we have the access control. So similarly, in the transport layer also, we have three important functioning. One is called the flow control, another is called the error control. And since here there is no media access required because we are already reached to the host, now we have to deliver it to the process. So the process may already be busy handling some data. So in that case, there could be a congestion control. So the congestion control. So remember these three important function of the transport layer. Apart from the port to port or the end to end delivery of the packet, it is also involved in flow control, congestion control, and error control. Okay. So now let us move to the important protocols, that is UDP and TCP. Transmission control protocol, and UDP is nothing but user datagram protocol. Now see, in the UDP protocol, this is for wireless and this is for wired communication. Wired communication. This protocol, UDP protocol, is simple, and this is not as simple as UDP. So since this is simple, so it is fast. So in comparison to TCP, UDP is simple and it is fast. But the major drawback of UDP is that it is not reliable protocol. So if it is not reliable protocol, what use it is? So yes, it is useful. You will see when you read IoT, where reliability does not matter, but speed matters. So in that case, you use UDP. So UDP protocol is not reliable. It is unreliable protocol. Just remember that. Unreliable protocol. Whereas TCP protocol is reliable protocol. So in UDP protocol, since it is simple and it is fast, so can we say that the headers in headers we are having like less number of bits will be in the headers, less number of fields will be there, simple header would be there so that it could be processed faster. So in IoT, where we have constraint on the like memory, constraint on the power consumption, so there is one protocol known as the Constrained Application Protocol, COAP. This COAP basically uses UDP protocol for transporting, or you can say for transmission. UDP protocol. Okay, this is an extra information. That's not related to transport protocol. So UDP protocol basically for wireless, it is simple and fast. It has simple headers and it is unreliable. For TCP, it is wired communication में use होता है. It is reliable. Okay. So basically, let us understand what TCP does. See, TCP, it is at transport layer. Okay. Before it, we have what? Session layer, presentation layer, application layer. From here, we are receiving bits of data, reaches to TCP. So, what we'll do, it will combine these bits of data into segments of data, into segment. So, transport layer, we call it segment. In data link layer, we call this combination of bits as a frame. Okay. So, also, it will have two buffers for storage. Why does it require two buffer for storage? See, one is called the sending buffer, and another is the receiving buffer. So there are two store buffer in TCP protocol. That is for storage. One is called the sending buffer, another is called the receiving buffer. So group of bits, what it does, see, actually what it does, I will represent the bits as 00, but it could be like anything, 0010. Let me say this like this. Okay, this is a group of bits. So what it will do, it will arrange these bits into groups, and each groups will be called as segment. Okay? And also remember, the segments need not to be of same size. The segments need not to be of the same size. So the segment need not to be of the same size. So this could be a variable size. So after grouping these bits into segment, what it will do, it will start naming this segment. So the first segment will be started by any random number. For example, let's say it is, for example, say 12. Any random number, the first segment will be named. Then the next consecutive segment will be numbered sequentially. After 12, 13, then 14, this segment will number as 15. Okay. What it does, it groups the bits into segments, and each segment is like given a number starting first randomly and then sequentially. Now, the TCP frame also has a header. The TCP frame has a header, and header length is same as the IP frame, 20 to 60 bytes. Also, also remember that the header length of TCP frame is also 4 bits, and the actual length is given by the content of this header length multiplied by 4. Okay. Now we have understood like 3 4 important points in the TCP. First of all, there are two buffer. That is one, number one is the sending buffer, number two is the receiving buffer, and the incoming group bits is grouped into segment, may be of same size, may not be of the same size, and then it is numbered starting sequentially, then it is number starting randomly and then sequentially. Now these segments is basically this TCP frame is will be having some header like this, and these segments will be handed over to whom? We have seen that these segments will be handed over to transport layer or network layer, and network layer we have IP frame, internet protocol. So this segment will be given to the internet protocol. Okay. Now let us understand that TCP connection normally consists of three phase. TCP connection normally consists of three phase. Number one is connection establishment. Connection establishment. For example, I want to send the data between two devices, a connection need to be established. Number two is transfer. Once the connection is established, you transfer the data. And number three is termination of connection. That after the transfer is complete, you terminate the connection. These are the three phases. Also, let us understand that the connection establishment is done in TCP protocol by a technique called as three-way handshake. It is called as three-way handshake. What is three-way handshake in TCP protocol? See, this is the sender, or we can say as the client, and this is the receiver, or we can say as the server. So before starting the transmission of the actual frame, it will first send the synchronization frame, and with this frame, it will send one ISN. ISN is known as the initial sequence number. Let me write it down. Initial sequence number. It will send one synchronization frame. Along with the synchronization frame, it will send the initial sequence number ISN. For example, say it is 1000. ISN is 1000. This will reach to the receiver. This is called first frame. Receiver will see, okay, when it received the synchronization frame, it will say, okay. It will send back what? Synchronization acknowledgement. That, okay, your synchronization frame is acknowledged. And it will send like ISN, what the initial sequence number it has received, it will add 1 to it. So this is basically to identify that, yes, I have received the correct synchronization frame. This ISN is used to identify the correct synchronization frame. So this will be nothing but 101. And it will send its again ISN, different ISN, that will be suppose 5000. So this will be received over here. So this sender will check key what I have got. I have got a synchronization acknowledgement. Okay. What is the ISN it has got? This return, it has written 5000 ISN. Okay. And 1001. So 1001 is nothing but one more than my ISN. That is the correct acknowledgement has been received. This is called second way. Now, the receiver also need to know that what I have sent has been received by the sender. Then only the connection will be perfect. Like say, the sender has initiated a request. Okay, receiver received it, but sender does not know it, okay, whether it has received or not. So say receiver sent the acknowledgement. Now sender knows that the acknowledgement has been received. So this knows that my connection is established, but the receiver does not know, because the receiver does not know the packet synchronization acknowledgement packet that it has sent to the sender has received by it. So to ensure that, it will again send the acknowledgement packet, and now it will only send the single ISN 1. That would be 5001. And this will be transmitted again to the receiver. The receiver will receive this acknowledgement. It will check what was it ISN. It was 5000. So it is expecting now 5001. And if it receives 5001, it means that the three-way handshake is complete and connection is established. Connection is established. So this is three-way handshake. So this is only the important things about the transport layer. Let us go through the notes and check what is there in the notes one by one. So we start from the transport layer here. So it provides end-to-end communication between the process, not just the host. Host, what do you mean by the host? That means the PC or the anything, LAPI or any device. So it will have its IP address. You do not only deliver to that host, but you also ensure that it reaches to the correct process. Ensure that data arrives reliably in order and without errors. Therefore, it has like the error control, congestion control, and flow control. See, this was the function of the data link layer, but instead of congestion control, it has media access control. But in transport layer, we have error control, congestion control, and flow control. So protocol, we have seen transmission control protocol. It is connection oriented, handshake before communication, reliable, that is guarantees delivery, retransmit lost data, order delivers data in sequence, slower due to overhead. UDP is connectionless, no handshake is done, unreliable, packets may be lost or no retransmission, faster because it has less overhead. Ports we have already seen, flow control, congestion control, error control is there. So now let us move to the application layer. So before application layer, what we have? See, before application layer, let us write here. We have the application layer. Then we have the presentation layer. And then we have the session layer, and then we have seen the transport layer, and above that we have seen. Well, these three layers are remaining. So if you remember the real world analogy that we talk about, wherein we were talking about the delivery of the packet from one location to another location, we in the third step, what we were doing, we were intimating to the sender that we have sent the started the we are going to send you the packet, be ready. So the same thing here does, it basically manages the session. Just remember the session layer, what it does, it manages the session. Manages the session means it will start the session, it will end the session, and it will maintain the session. Maintain the sessions means, suppose if the session ends before the transmission completes, so it will restart the session. That is called maintaining the session. It will start the session, end the session, and it will maintain the session. This is the like the function of the session layer. Okay. Also, the session layer is responsible for dialogue maintenance. That whether it is the simplex or duplex communication, what types of communication is taking place. Okay, so this is the session layer. So now so the two important function of the session layer is, number one, it manages the session, and number two, it maintains the dialogue. Dialogue means the communication. It may be like simplex or duplex. In duplex, it may be half duplex or full duplex, that we have already seen. Now coming back to the presentation layer, what was done in that real world analogy? We have seen that proper packaging was done. So the presentation layer will be basically responsible for what? For encryption. That is, data should not be, before it is transmitted, it should be encrypted. So encryption, data translation. Obviously, data translation. It should be translated to the codes which is understood universally by all the device, irrespective of what you are sending. Then, if it is doing encryption, it should also be do decryption also. Okay. Then compression and try to reduce the size of the data. Compression and decompression. Just remember there is no protocol involved in it. Just need to remember the function serialization and deserialization. Okay. And application layer, we all know that application layer is responsible for the providing the application like email, or you have file transfer protocol. All that application through which you transfer the data is part of the application layer. So, see, in presentation layer, what we are doing the encryption of the data and decryption of the data. We have data translation has been done, conversion to the proper code, then compression and decompression of the data is taking place, and serialization and deserialization of the data is taking place. In session, we have seen that session is responsible for managing of the session. That is, starting the session, ending the session, and maintaining the session, and also maintaining the dialogue. Dialogue means simplex communication or duplex communication. In application layer, let us move to the nodes and see what is there in the application layer. It will basically comprise of the different applications. That is the closest layer to the end user. That is the layer number 7. This is the layer number 7. And provide services like web browsing, file transfer, email, DNS, networking management, etc. The major application layers protocol are HTTP, HTTPS, Hypertext Transfer Protocol, and Hypertext Transfer Protocol Secure. File Transfer Protocol, Domain Name System. These are the protocols that we use at the application layer. From email, we have the Simple Mail Transfer Protocol, Post Office Protocol version 3, IMAP Internet Message Access Protocol. Just remember the name of the protocol that comprises the application layer. Then we have the Dynamic Host Configuration Protocol and Simple Network Management Protocol, SNMP. Do not need to go in detail of all this protocol. Just you need to remember the name of this protocol. So we have the different protocols running at the application layer that allow us to use different application. For example, IMAP is used to send mail applications. Okay, mails. So this is IMAP, Internet Message Access Protocol. SMTP is also for simple mail transfer protocol for mail. POP3, just remember the name. DSCP, SNMP, these protocols are an application layer protocol. So This way, we have completed the OSI model, and with this OSI model, we have also completed the computer networking. Although it was a long video series, but I hope you have gained much from this video series. If you have really liked this video series, then give me a thumbs up and do share your feedback on the in the comment section. Thank you for being with me for such a long time in this entire duration of the video series. Have a good day.